So let us start with the first chapter of some basic concepts of chemistry. I mean, let us start with the first chapter of chemistry of class 11. We had, this is the second time I'm recording actually, because we had already gone through the chapter fully. But unfortunately, we spent time on things which were not needed, which are not asked. Yes, which can be read for our own enjoyment, but they are not asked, sadly. So it's not like we are just learning for exams, but then we will miss the point of chemistry when we read that because um yeah, because we'll not miss the point of the philosophy of chemistry, but then we'll miss the point of understanding the theoretical parts of chemistry. We will indeed go through the philosophy of chemistry, because that is, as scientists, as young scientists, we have chosen science in our 11th and 12th grade. We are willing to give some of our life to science as a field, to study science. Thus we should already start thinking like scientists. Thus, we should understand what the philosophy of chemistry is, as the NCRT suggests. But then we should also focus on the theoretical aspects of it. Um, what the theory of chemistry is. What the theory of chemistry actually is, and not only on philosophical parts of it. So philosophy is important, and but theory is also as important. What I'm saying is what I'm saying. So, the philosophy, if we have just one look at it, any theoretical part, in how much ever we learn, we will look at it from a philosophical lens, any theory part. But then any theoretical part, any philosophical part, we cannot look at it from a theoretical lens, right? Because that is just not possible. If you have information, you will look at it with theoretical lens. You can skip this part of the lecture, but this is just me trying to justify why we are not putting that much time into learning the philosophical aspects of chemistry. So we have to the objectives of the chapter is to appreciate the contribution of you know India in the development of philosophy, explain the characteristics of the three states of matter that we've already learned in ninth grade, right? Classify different substances into elements, compounds, and mixtures, which again we've learned in the ninth grade. Use scientific notation and determine significant figures, which we have done in physics first chapter, in the first chapter of physics. Use and then differentiate between accuracy and precision, which is rather important. We will learn about it. Yeah, and define SI units and base physical quantities from one system of units to the another. We've learned this in physics. We will look at it again. Explain various laws of chemical combination. Appreciate the significance of atomic mass, average atomic mass, molecular mass, and formula mass. All of these, these masses are very important because, um, yeah, they've helped us in a lot of things in chemistry, right? Even the laws of chemical combination have explained a lot of phenomena in our world, right? Calculate, describe the terms mole and molar mass, which we will do slowly. Yeah, this all of these are things that we've already learned. There's just one new thing, which is determine empirical formula and molecular formula for a compound from the given experimental data and perform stoichiometric calculation, which is a new thing, and calculate the mass percent of a component elements constituting a compound. Mass percentage, if you don't understand it, it's completely fine. First, we will start with the summary because it's a ritual in our platform, Fantastic Studying, to always start with the summary and then go on to start with the chapter. This is done because so that we can understand what the chapter is about, not only jabba 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 jabba, right? So that we can understand the philosophy of the chapter. Because when we learn the philosophy of the chapter and what they are trying to teach us, we focus on understanding the chapter rather than just studying it for exams. So we've got to, as students, we've got to look at both aspects, right? Learning and exams. You cannot do just with one, right? Because if you don't learn properly, there'll be problems with solving advanced equations and advanced problems. Yes, you'll be able to score a lot in your board exams because you're able to memorize a lot of things, but you will not be able to do a lot of things. You'll not be able to understand. You'll not be able to solve very huge equations. You'll not be able to understand very complex processes and phenomena. Thus, it's very important to understand as well as apply. So, we will start with this. Yeah.
Chemistry, as we understand it today, is not a very old discipline. People in ancient India already had the knowledge of many scientific phenomena much before the advent of modern science. They applied the knowledge in various walks of life. The study of
So, chemistry as we understand it today is a very new thing, right? It's a rather quite new thing. But, ancient people understood certain scientific phenomenon before the modern chemistry came in, right? And they applied the knowledge through every many walks of life, right? So they didn't have as much as idea of chemistry as we do now, as how we are able to gather so much data and put it into words, right? They didn't know all of this, why things happen, but then they knew things did happen. As you can see, there are records of mercury lingam in India. So they did not know why this mercury lingam, this pure this thing liquid state could become into something which is solid. uh, Now we do it. It is because it is an alloy. It's not pure mercury. It's an alloy of mercury. Thus, it becomes solid. But they did not know this, right? They at that time they did not know why, but then they did know what happens. So with this knowledge, they applied this in various walks of life, and thus they had fun, I guess. The study of chemistry is
of chemistry is very important as its domain encompasses every sphere of life.
so okay. Let's do a quick exercise. Okay, uh, pause this video for 5 minutes, and we will note down um at least 5 areas where chemistry is used. Right? Ready, set, pooey. So these are 5 things that I listed. Our brains, yes, our brains is chemistry. It has hundreds of chemicals. Our every thought can be measured. It can be measured if you're thinking happy or sad thoughts right now. It can be measured if you are a happy person in life or a sad person in life, or a very calculative person or a stingy person, or a very kind person. It can all be calculated. through chemistry. Oh, chemistry. So, and then books are chemistry, obviously. Paper is polished and put through various chemicals to make paper, and with that paper, it's binded. Books are a part of chemistry. Electricity. This is very new for a lot of people, but electricity is chemistry. How? Let's find out. So yes, electricity is the process of electricity. That is, the flow of electrons is cannot likely it is chemistry. Any kind of movement, it cannot be termed as chemistry though. But then why electricity happens is because of chemical reactions inside a cell. The flow is because of chemistry. The flow itself is not chemistry, or it could be in many definitions, but why electricity happens is chemistry, because of various chemicals inside a cell, a battery. And then we have plastic is made up of millions. It's made up of not millions but tons of chemicals. So it is mixed together, and then that gave birth to plastic, and it's everywhere inside our bodies, inside our food, inside newborn babies. It's everywhere, plastic. Then we have wood is also chemistry. Anything organic is also chemistry. Our bodies, our brains, um, wood, anything and everything is chemistry. So what did we understand by this? Everything in this world is chemistry because it is made up of atoms or molecules. So wood is made up of atoms and molecules. So it is also chemical, right? It is chemical in nature. It's chemistry. So after we've done that exercise, we will understand better what the textbook is trying to tell us.
Chemists study the properties and structure of substances and the changes undergone by them. All substances contain matter, which can exist in three states: solid, liquid, or gas.
We've learnt this in fourth, fifth standard, right? Solid, liquid, gas. Lol. So, yes, solid, liquid, gas. And again, they're teaching the same thing. I know they should have given us the fourth or the fifth state of matter. Both Einstein condensate and plasma, right? But they didn't. Idiots. So everything which contains matter. So chemists, people who are related to chemistry, are called chemists. They study the properties and structure of substances and changes undergone by them. Simple as that, bro. Structure of substances and all of the constitute particles. Okay, I'll just let the textbook read itself.
Gas. The constituent particles are held in different ways in these states of matter and they exhibit their characteristic properties.
So the constituent particles. What is the meaning of constituent? Which makes all of these states of matter. Constituent. Can you remember something? In class 9 we were learning, right? Constituency. So many constituencies. Like there are nearly 500 constituencies in India, right? All of those constituencies uh, together build India. So similarly, the particles that build the states of matter, are held in different ways. Held means are put in different ways. Thus, um, they exhibit different characteristics, right?
Properties.
How are they held and how differently are they held? We will learn it. we will learn it, but for now they're held in different ways, because of which they have different characteristics and properties.
Properties. Matter can also be classified into elements, compounds, or mixtures.
So it can be classified into elements, compounds, and mixtures. What are elements, compounds, and mixtures? It's right here. Just
Mixtures. An element contains particles of only one type, which may be atoms or molecules.
particles of only one type. Atoms and molecules are particles. So let's say something has only one type of atoms. So it is an element. So let's say you have only red color balls. So one one type of particle, right? That you know can be termed as an element, but not quietly. But in our definition, in our bacha definition, it can be termed as an element, right? It's just like having same type, one and only one type of anything, of atoms and molecules, yeah, together. That is called an element.
Molecules. The compounds are formed where atoms of two or more elements combine in a fixed ratio to each other. Each other.
So compounds are which that two or more elements combined in a fixed ratio with each other. Um, like let's say H2, H hydrogen, which is a hydrogen molecule, and oxygen are, what are they? They are two elements, right? They are made of the same components. If you don't understand this, it is completely fine. This is a very quick summary of the this thing. We are just looking through what this chapter holds, right? Right. So when these two like mix, we get H2O. Right. I want you to take this time and write down whatever you don't understand. Right. You don't understand about elements, right? Elements, I don't understand them. Don't understand about compounds, write about compounds. I don't understand what is compounds. If you don't understand some part of compounds, I don't understand this part of compounds, right?
Other. Mixtures occur widely and many of the substances present around us are mixtures.
Mixtures occur widely in um but then what are mixtures, right? They are not telling us what are mixtures, but they are telling that many of the substances yeah, around us are mixtures.
Mixtures. When the properties of a substance are studied, measurement is inherent. The quantification
What is inherent? Inherent means measurement is unavoidable. Measurement will always happen, right? When properties are studied. Or let's find out if people don't understand the meaning of inherent. So, inherent means existing in something as permanent, essential, or characteristic attribute. So, measurement is permanent. When we are, when we are studying properties of a substance, you will measure it, right? What if you're given a line, let's say, if you're ever given a line like this, like this. So the first thing you'll do is to take a scale and measure it, right? The first thing you'll do is taking a scale and measuring it. That will be your first idea, and then you will check for other things, like if it is pi, how how should we use it and everything, right? If you're learning about its properties, the quantification of properties requires a system of measurements and units in which the quantities are to be expressed. So when you let's say you've gotten a scale and you've yeah, you have measured this line. What do you do about it? You will have to look at it with certain units, right? What units? You'll have to look at, let's say this is 1 centimeter, 1 cm. This is, yeah, this is 1 centimeter, this is 1 centimeter, this is 1 centimeter. But what is 1 centimeter? Who defined it? Who defined a centimeter? What is it? Why are we using it? Right? We've learned this in detail in physics chapter 1. Thus, I will not be teaching it here. That is why, we will look at it later. Yes, we will look at it in detail in units 1, physics chapter. So, who decides the centimeter? Who decides how much is a centimeter? So, that is what they are telling, right?
Quantification of properties requires a system of measurement and units in which the
What is quantification? Quantification means counting of properties. Let's say you have to count, you have uh, candies. Candy, you have candy. How will you count all of these candies? When you know numbers only, you'll count, right? How will a 3-year-old count? He doesn't know how to count, right? This is 1, 2, 3. He'll tell like that. But you know how to count. You are a smart buddy. So you will count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 candies. I have 10 candies to char. Yeah. So yeah. Uh. So what is 1, 2, 3, 4, 5, 6, 7? What is 1, 2, 3, 4? It is a unit system, right? It is a unit system. So similarly, we have a unit system of centimeters, meters, kg, kilogram, grams, all of these things, right? So 1, 2, 3, 4 is a unit system. That's why it's called a unit system.
quantities are to be expressed. Many systems of measurement exist, of which problem 1.8
Ah,
some basic concepts of chemistry 25. The English and the metric systems are widely used.
so many in the world, there are so many countries. Each country develop their own measurement, right? Own measurement system. In India, they had developed this thing, Indian measurement system. So they had like all of this. They had a tire or something. They had for measurements of length, right? Yeah, they have tola. They say, right, how many tola is this necklace? Blah 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 blah. So, what is tola? All of these things only. So Tola is, again an SI unit, something like an SI unit, but SI units are different. SI units are made by the International System of Units, but it is a unit, right? So they have Tola, they have different, really different things they had in their time. And then they have one Dhan, which is weight of one wheat berry. What is berry? One wheat packet. They had a huge packet like this. That is called a dhan. And then four chawal, four grain of rice. And then four dhan is one rati. Rati. Okay, wheat berry. Wheat berry is okay. Wheat berry, I understood wrongly. Wheat berry is that one seed of wheat. That is one dhan. Four dhan is one rati. So they had such small units of measurements, right? Of length. Of length, if we see. Of length, we had, yojana or krosha. Yojana kar rahe the. When you listen to this word, yojana means planning, right? But yojana also means measuring, right? When you plan, you measure the scale of your idea and stuff, all of that, right? So we have palm length, we have tula of gold, we have arm length or the owner. We had so many things, right? So um every place in the world had different, systems, different systems. But the English one and the metric one are used a lot. What is the English system of unit? We will learn about this in physics class 11. Yeah, physics, first chapter. Which is we've already uploaded the video. Go watch it, you idiot. No, just kidding, just kidding. You are my pyara boo boo baby. Boo boo baby. So yeah.
Used. The scientific community, however, has agreed to have a uniform and common
So metric systems are widely used, but then slowly the scientific community started using, SI units, so that in any science, in the whole of science, let's say some Indian scientist, or let's say some African scientist, or Singaporean scientist, you know finds some groundbreaking. But how will he, tell that it is this weight? He'll have chinky eyes. Hey, chinky is a bad word, don't use it. I used it because I'm an idiot. Hey, shut and sit there. Sorry, that was my brother. Okay, so they'll have little small eyes and all of that. So he measured something which is like 100 tons, right? How will he tell that it is 100 tons? And let's say the whole world uses kilograms. The whole world uses kilograms. He only uses tons. In Singapore, they use tons. How will he tell that it is kilograms? How will he tell the world it is 100 tons? Right? So that is why the whole of scientific community, the whole world, in the whole world, the whole of scientific community, you know, the whole scientific community all over the world, you know, spoke of only one unit of systems, which is the SI units, International System of Units. Finish. Problem finished. So what are these units? We will learn it. Be patient. We've already learned it in physics class 11. Chapter 1, lecture, not one first, on the first lecture, but then the second part of it. So, chill, Marty, baby.
system throughout the world, which is abbreviated as SI units, International System of Units. Since measurements involve recording of data, which are always associated with a certain amount of uncertainty, the proper handling of data obtained by measuring the quantities is very important.
So, measurements is not only taking a measurement, right? Because if you take a measurement, you'll forget it. No point of taking the measurement, right? So that is why you have to remember it properly, and you have to, remember that there could be, with the scale, right? Let's say your scale is broken, right? Let's say your scale is broken, right? If your scale is broken, what will you do with it? Brother is like, throw it. So if it's broken and you only have this part, right? You only have this part, right? What will you do then? You will, calculate from this part, right? You'll calculate from this part and mind that this has certain amount of difference. It can be plus or minus 2 millimeters. There could be a difference of this much, right? So that is the idea behind this. There could be some amount of, uh, you know, mistakes that could happen. We have to leave some space for mistakes, and there should be a proper handling of data. You have to write it properly, right? In many, many, many places, in many countries, what happens is these idiot fellows from the government, right? Some idiot fellows, not all. These government fellows know what they'll do is they'll write that we spent more money on something, some project than they actually did. Let's say they spent 10 rupees. Okay. And then this guy will write off 20 rupees they spent. So the central government, so the central government will give them 20 rupees. So this guy will take off this 10 rupees. This 10 rupees he'll give off here. This 10 rupees he'll take off for himself. 10 he'll give off here. 10 he'll take off for himself. And he'll have fun. Lol. My brother is laughing. 10 rupees only, yeah. What kind of government is this? In 10 rupiah, at least one daru bottle. He's like, in 10 rupees, one daru will also not come. Hey, shut up. We are all students here. No daru. No daru waru. No alcohol. So, yeah. So, that is why don't give measuring and handling of data to these idiots, right? You have to handle data very nicely, very properly. Properly is important. Properness is important. The properness of handling data is very important.
Important. The measurements of quantities in chemistry are spread over a wide range 1 to 10 plus 23.
So, measurements of quantities in chemistry are spread over a wide range. So, chemistry is everywhere, right? Chemistry is everywhere. So, obviously, we'll have these huge numbers from 10 to minus 31, 10 to minus 23. How is chemistry not everywhere, da? You tell. In feelings? Feelings are also chemistry. Feelings can be measured through MRI scans. Feelings is the amount of certain chemicals you have in your brain. If you have more of oxytocin, you'll feel more love, right? Oxytocin, you'll feel more love. So feelings are also chemistry. What else do you think is not chemistry? I can say your goggles. My specs are also chemistry, because specs are made up of Specs are made up of atoms and molecules. So it is also chemistry. It is also made of chemicals. Glass is also chemistry.
My stupidness.
Huh?
My stupidness.
My stupidityness?
Hey, बेड़ा क्या कान का पे लो?
Your stupidityness.
Yes,
Anyone's stupidness.
yes.
Yeah, stupidityness can also be measured
But my
through
stupidness
chemicals.
can't be measured
How cannot it be measured?
because my stupidness processing.
Very nice. My brother is roasting himself only. Go study, idiot. Let us study, you also study.
हमारे ब्रेक ले रहा है भैया ब्रेक तो ले लो बच्चा हो 11 साल का होगा
Lol. So, chemistry is everywhere. Even my brother could not prove that chemistry is not everywhere, right? So, so it has a wide range of measurements from 10 minus 31, which is 0 point, which is 0 point 0.00000, sorry, which is not 0 point, which is 1 point, wait, it's not this one, which is 0.00000, which is 0.00000. After 30 zeros we get one. This one we'll get. At the same time things range up to 1 after 0 0 0 0 0 0 0. We can write it till 23 times. 23 times we can write the same zero. And that is how huge things are in chemistry. In chemistry things are big but also small, right? Point 0.0000000000000000000. Okay, let me do that again. Point 0.000000000000000000001.
that was not zero that was zero
I know. I wanted you to feel how small it could be. That is why I told it, right?
0 to 0
Two.
का नाम
It could be, that small. Two. One. Uh, 1, 10, 100, 1,000, 10,000, lakh, 10 lakh, crore, 10 crore, 100 crores, 1,000 crores, 10,000 crores, 1 lakh crore. We didn't come even half also. We just came half, okay? 1 lakh crore, 1 crore, 1, 10 crores, 10 crores, 100 crores.
इतना पैसा में तो भी अच्छा होता लेकिन
Yeah, if we had so much money, we could have lived aram se. 1,000 crores, 10,000 crores, 1 lakh crores,
एक साल वाला तो भी ड्यूटी हो
crores, 10 crores. Oh my god. And then 100 crore, uh, crores in 1 lakh crore.
मारो
That is 1 lakh, 1 lakh crore, 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 crore. That's how big things are in chemistry and how small things are in chemistry. 0.000000000.1 something, right? So I wanted you to feel how big and small things are. That is why I counted that, right? Let's move on. Let's move on. That was a very funny session.
23 hence,
Time
a
for geometry.
convenient system.
Hence, a convenient system of expressing all of these big numbers. See, everywhere you cannot write 1 lakh crore, right? How will you write 23 zeros together? And how will you write 0.00000000100 till 30? How will you write 30 zeros and write one after that? One after that. That'll take a lot of time to write. That is why we've come up with scientific notations. What is scientific notations? Check the units and dimensions videos now, right? Even if you check the summary video, I'll be proud of you. Go and check it out, right? So yeah, what is scientific notation? You will learn through that. If you don't understand what scientific notation is, write it down. We will while we learn the chapter, you will get to know what is scientific notation, right? Science is about exploring. It's not knowing everything together, right? We will understand it. Don't worry.
System of expressing the numbers in
I'm not going that deep into this chapter because we've learned all of these concepts already in class till class 10th. So pardon me for not explaining this chapter till the very end. I mean, till the last layer is open, right? Because we've seen all the layers open, man. It's boring.
scientific notation is used. The uncertainty is taken care of by specifying the number of significant figures.
So, what is uncertainty? As we learned, uncertainty is, some mistake in measuring, right? How is that taken care of? Through the, application of significant figures. What are significant figures? We have a separate video on that with rules to find out what are significant figures. Check it out. Yep.
Figures, in which the observations are reported. The dimensional analysis helps to express the measured quantities in different systems of units.
What is dimensional analysis? Yeah? Too big of a word, no? I'll explain. What is dimensional analysis? Let's say you have 1,000 meters of cloth. How will you convert it into 1 kilometer? It is 1 kilometer only, no? What do you have to convert? So, ladies and gentlemen, I present you the dimensional analysis. So yeah, that was it. That was it. That is it. Dimensional analysis. That is it. Dimensional analysis is converting something, into other system of units. Let's say you have, 1 meter of cloth and you want to convert it into 1 kilometer. I mean, you want to convert it into kilometers. In kilometers, you want to convert it, right? So what will that be? 0.0.001 kilometer of cloth, right? That is it, ladies and gentlemen. That was dimensional analysis, converting things, and to interconvert to from if you have 0.0, you have 0.001 kilometers of cloth, and you want to convert it into meters. You'll get 1 meter of cloth. That is simple, baby. Yeah.
Units. Hence, it is possible to interconvert the results from one system of units to another.
So it is possible to interconvert. It is not only possible to convert, but it is possible to ulta. Ulta convert is used. So scientific figures, dimensional analysis, significant figures, scientific figures. I'm saying scientific notation, significant figures, dimensional analysis. Everything is done. We've understood what they are. If not, we'll understand it in deeper terms slowly.
Another. Another. The combination of different atoms is governed by basic laws of chemical combination, these being the law of conservation.
So combination of different atoms. That is any chemical reaction in the world. any chemical reaction. So they are, governed by some basic laws, like laws of conservation of mass, law of definite proportion, law of multiple proportions. We've learned about all of these three in class ninth, but we have two new laws, that is Gay-Lussac's law and Avogadro's law, which we will learn this year. Yeah, and then all these led to the Dalton's atomic theory. What is the Dalton's atomic theory? We've learned about it already. Dalton's atomic theory is that everything in the world is made of atoms. And turns out he's right. Everything is made of atoms.
Conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volumes,
It's Gay-Lussac, not Gay-Lussac's.
and Avogadro law. All these laws led to the Dalton's atomic theory, which
Atomic theory. Atomic. Atomic theory. Okay, wow, I love playing with accents.
states that atoms are building blocks of matter.
So the Dalton's atomic theory talks about how everything in the universe is made of atoms.
Matter,
And matter is made of atoms. Not everything, but matter is made of atoms.
matter. The atomic mass of an element is expressed relative to 12C isotope of carbon.
So there is something called atomic mass from the atomic theory. We have deduced something called the atomic mass. What is atomic mass? A mass of an atom, right? But how do we know how much weighs, right? So for that we take the C12 isotope of carbon, and we tell that it has exactly 12U. So what is the C12 isotope? So C12 isotope is the isotope which we can find anywhere and everywhere, right? It has 12, so they are mostly found. C12 is the this thing which is mostly found, and it has like, and which is the most stable state of carbon, right? So it is found 98.93% in the element form, in the element form. Baki too, they mix with other things, other elements, and become compounds. But in this, C12 is mostly found alone. Basically, this guy is a lone wolf. Understood, like many of us. So this guy has 12 electrons, two electrons in the outermost shell, and 8 electrons in the second shell. Sorry, 8 electrons in the second shell and 2 electrons in the innermost shell. Right? Image. Let's look at an image. So it looks okay. We don't have a picture of it, sadly. So that is C12. So it has 12 atoms, right? 12 protons. So from that, 12 protons and neutrons. So what we tell is that uh, you know it has exactly 12 U atomic mass, right? So the isotope of carbon which has exactly 12 U, that means you know anything more than that will be the mass of the atom of C isotope is 12U. 12U, right? So with that, with anything in the future that comes, it'll be plus it will be a multiple of 12U, right? It'll be 1 into 12U, it will be 2 into 12U, it will be 3 into 12U, it will be half into 12U, right? If you don't understand this, don't worry. Many of us don't do. I I didn't understand this either when I first read it.
Carbon, which has an exact value of 12 U. Usually, the atomic mass used for an element is the average atomic mass obtained by taking into account the natural
Usually, the atomic mass used for an element is the average atomic mass obtained by taking into account other natural abundance of different isotopes of that element. Usually, an atomic mass used for an element is the average atomic mass obtained by taking into account. Didn't understand.
abundance of since measurements involve
NCRT uses these, very complex languages.
has agreed to have a since measurements exercises. 1.1 exercises. Since measurements involve recording of data,
Here you have to read, man.
has agreed to have a uniform and common system, since measurements exercises.
Hi,
Since measurements involve
मेरा बहुत बैंगलोरियन accent है ना. Bangalorian accent है ना.
Mm,
Huh?
mm.
Oh my god, that was recording. I'm so sorry.
Very good.
I'm trying to make this work.
has agreed to have a uniform and common since measurements
Ah,
involve
leave only one paragraph to read now. I'll only read off. So usually the atomic mass is used for an uh, element of usually the atomic mass you use for an element is the average atomic mass obtained by taking into account the natural abundance of the isotope of that element. What does this say? Okay, so usually, see, there are many different isotopes, right? Like here for carbon, we have three isotopes here. So which isotopes? So this will have different mass. This will have different mass. This will have different mass. Why? This has less number of protons. This has more number of protons. This has even more number of protons. So which mass should we consider? Right? We consider something called which is an average atomic mass. So let's say this thing C214 is you know found very much. It's like 95%. It's 95%, right? This one is 2%, and this one is 3%. This one is 3%, this one is 2%. This one is 95%. That is it. That is it, bro. And so the mass of this is 12, the mass of this is 13, and the mass of this is 14. So we'll mostly take 14, right? Because this is 95%. This and all we can, you know, we can ignore. So that is the idea behind this. So the average atomic mass will be 14 because 95% is the most. That is the basic idea, right? That is it. That is it what they are talking. The molecular mass of a molecule is obtained by taking the sum of atomic masses of different atoms present in the molecule. So yeah, that is it. So let's say you have you have a packet. You have Kinder Joy of Kinder Joy. This one. Kinder Joy, baby. So in Kinder Joy, you have toy. This is toy.
Oh, wow,
This
what a
is
toy. It looks like Alu.
Looks like aloo. And this is chocolate. So this is chocolate, right? That is chocolate. That is toy. This is chocolate. So what will be the mass of this one Kinder Joy? It'll be the mass of this toy plus the mass of this chocolate is equal to full Kinder Joy. Yeah, that is it. That is it. You have understood the concept of molecular mass, baby. So let's say a mole is made of two things, H2 and O. So the whole mass will be the sum of H2 and the sum of O. So thus you'll get H2O ka mass. Simple as that, bro. Simple, simple, simple. And then the molecular formula can be calculated by determining the mass percent of different elements and compounds. Okay, this we don't understand. Shit. What is this stuff? What is this? No understanding only. Some basic concepts of chemistry. We will write it as you know things we had not understood. We had not understood. Understood. So some things were, what were the things? Mass, molecular formula. Molecular formula. So it's okay to not know certain things. We will learn it, right? We will learn it later. And then this is something that we've learned already. The number of atoms, molecules, or any other particles present in a given system can be expressed in the Avogadro's number. So one mole of yeah, we will learn about the Avogadro's constant too. Avogadro's constant is also not that clear, right? For us, Baki things are kind of clear. If not for you, you should make your own list. Things I things I have not understood. And I don't even understand stoichiometry. So chemical reactions represent the chemical changes undergone by different elements and compounds. A balanced chemical equation provides a lot of information. So a balanced chemical reaction, chemical equation, you know, provides a lot of information about what happened, to, what element and what compound, right? It provides a lot of information. The coefficients indicate the molar ratios and the respective number of particles taking place in a particular reaction. The quantitative study of reactants and products is called form stoichiometry. So we don't understand stoichiometry, right? Using stoichiometric calculations, the amount of one or more reactants required to produce a particular amount of product can be determined, and vice versa. Hmm. That was very complex. Thus, we will also write stoichiometry as something that we do not understand, right? So we'll write this, and we have three concepts that I have three concepts that I don't understand: molecular formula, Avogadro's number, and stoichiometry. If you have access to the internet, I would suggest you to search for these concepts on your own and try to chip all of these ideas before the next class. But in the next class, you are anyways going to understand this very aram se, right? So yes, thank you so much everyone for this class. We have finished the summary of some basic concepts of chemistry, and we have learned quite a few about the quite a few things about the chapter and what we are going to encounter in our next classes. Thus, I would like to bid goodbye. Yeah, goodbye, everyone. Yeah. Bye bye.